Okay, so we're going to learn how to run an analysis of covariance in Ancova in SPSS. And I'm using the data file SPSS for YouTube.save. SPSS for YouTube.save. So within this data file, we have grade 11 LAL scores, grade 11 language arts scores. So we want to see if there are significant difference in grade 11 LAL scores based on school while we control for the grade 8 language arts scores. So remember, an ANCOVA is testing one main effect or one independent variable, in this case, school, which there are approximately 2 levels for, while it controls for a continuous variable or scaled variable, in this case, grade 8. We know grade 8 or past performance has an impact on present performance, which would be considered a grade 11 scores. So we want to make sure we can control for this variable when we test to see if there are significant differences between schools, which is our main effect. So if you remember from class, ANCOVA, we can run an ANCOVA provided that the main effect, in this case school, does not interact with the covariate, in this case grade 8 LAL. So the first thing we have to do is we have to test to make sure that these two variables do not interact together. And the way we do that is we select Analyze, we go down, we select General Linear Model, and then we select Univariate. Our univariate window pops up, so we want to place from the list of variables on the left hand side grade 11 LAL into the dependent variable box. Our main effect, or our main independent variable, is going to be school. We want to see if there are significant differences between the two schools. And our control variable, our covariate, is going to be grade 8 LAL, which we put in place in the covariate box. At which point we then go up and we click on the model button. Window appears called univariate model. You'll see full factorial is selected. We don't want that. We want to select custom. These variables then become active. We want to take them, we want to place them over into the model window. So we place school, we then place grade 8, and most importantly, we multiple select grade 8 and school by holding the control key down while clicking on them, and put them both over there so we get an interaction term. We click continue, and then we click OK. What we get is we get our check for interaction. That's all we've done here. We've wanted to check for interaction between school and grade 8. School, our main effect, grade 8, our covariate. And as you look at the test of between subjects effects box, you'll go over and you'll see that this interaction is not significant. So since this interaction is not significant, this means it will allow us now to run an analysis of covariance. So I simply close that window. I don't have to save this output. I'm going to go back up to Analyze because now I'm going to run my true analysis of covariance. I select Analyze, go to General Linear Model, select Univariate again. You'll notice that the variables we had in there are still there. Most important, we want to hit reset again and rerun the process. We hit reset again and rerun the process. Grade 11 is our dependent variable. School will be our main effect or fixed factor, our independent variable. We're looking to check differences between school and the grade 11 LAL. And grade 8 LAL will be our covariate. At this point, the only thing we really need to do for an analysis of covariance is select the Options button. A new window pops up, says Univariate Options. We want to select School from the left-hand side window and put it over into the right side, Display Means for, and it says School. We want to compare main effects. We leave the LSD none, which is here. We leave that. We don't need to change that. And then we go and we select our display data, descriptive statistics, estimates of effect size, observed power, and homogeneity tests. Click continue, and then click OK. Once I click OK, You'll see I get school A, the 70 students, school B, 144 students. Before the control variables added in, there's a difference. School A's mean was 236, school B's mean was 240. So there's difference roughly of 4 points. Is that difference statistically significant? We're going to find out. The Levine's test for the equality of variance happens to be not significant, which is always a good thing. Although Ancova is fairly robust, so even if this was significant, we're fairly confident with the Ancova that even when this is significant, providing that the sample sizes are somewhat similar, it shouldn't be a problem. Here, they weren't somewhat similar, so if we did have significance in the Levines, we might have a problem with this Ancova. However, it is not significant, meaning that the equality of variance is equal across both groups. Now we go down to our main output, the test of between subject effects. We look at grade 8, which is our covariate, and we see that grade 8, the covariate, is significant, which is oftentimes the case, that the covariate will be significant with the dependent variable, which is grade 11 LAL. But our main variable of interest, which was school, that's our main effect, we find is statistically significant. So there is a statistically significant difference between grade 11 mean scores between schools. The power is 0.841, which is starting to get close to 1. 0.8 is considered a fairly strong power, 1 being a very strong power. So that's good. The next thing we look at is our partial eta squared. So in this model, the partial eta squared, school accounts for 4% of the variance in grade 11 LAL, and grade 8 LAL accounts for 34%. We simply take the partial eta squared, move the decimal over 2 places, and interpret it as a percent. To determine the effect size for each one of these variables, we simply take this partial eta squared, 0.040, and we take its square root. When we take its square root, we get a value of 0.2. We know Cohen's, that's a moderate effect size. Of course, if we take 0.34 and take its square root, which is a 0.58, which is a very, very strong effect size. So the covariate is playing a very strong part in this entire model. The entire model actually explains 34.4% of the variance in grade 11 LAL. So these two variables combined account for 34. The adjusted R squared accounts for 34.4% of the variability in grade 11 LAL, with grade 8 contributing the most to that. But school also happens to contribute about 4% to that. Now we go and we take a look at the estimated marginal means, and when we look at the estimated marginal means, notice how the mean scores have changed. Now this is taking into consideration the covariate, the grade 8 LAL. So school A's mean is 235, school B's mean is 240, for a difference of 4.8. And this difference is statistically significant, and we can tell that from our pairwise comparison box here. So school B does score significantly higher than school A on the grade 11 LAL.